So we come to the next part of sensory system, that is sensory homunculus. So the sensory representation in the postcentral gyrus has a typical pattern. The sensory representation in the postcentral gyrus has a typical pattern. The body is represented upside down with the legs above and the head below. Here you can see the head portion, with the face, with the lips, with the tongue, etc. With the tongue, this portion of the head portion is situated below, whereas this is the legs. The leg portion is situated above. And the area of representation in the cortex of individual part of the body is proportional to the number of receptors in that part of the body. Here you can see this is the face region. This is the face region and these are the lips. The lips are very big. This is the thumb. Thumb is very big. The fingers and hand area are very big because these are proportional to the number of receptors. These are proportional to the number of sensory receptors. So each part of the body has been distorted in proportion to the sensory representation in the cortex. You can see that each part of the body is distorted in proportion to the sensory representation of the body. So just now, as you are told, the lips, the face of the face or the mouth region, the thumb and the fingers, the hand, they are very large because they have large number of sensory receptors in that area. So this distorted view of the sensory representation in the cortex of individual body parts, this is called sensory homunculus. Here you can see the thumb, fingers, the lips, parts of the mouth, thumb and the fingers with the highest number of sensory receptors are disproportionately big in the map of sensory representation, and this is called sensory homunculus. So this figure is called a figure of the sensory homunculus. This represents the very large representation of the body parts in proportion to the presence of sensory receptors in the body. The part which has the largest number of sensory receptors is the biggest. So that is about the sensory homunculus. Now next we come to rexed lamina. Here you can see the cross section of the spinal cord and the grey matter. The grey matter, this is the grey matter. The grey matter is centrally situated in the shape of a butterfly. This is the shape of a butterfly that you can see. This is the grey matter which is centrally situated, and this encircles the central canal. And is divided into anterior, lateral and posterior horns. The anterior, lateral and posterior horns. And Rexed divided the grey matter into 10 layers or laminae according to histological pattern. The posterior horn is divided into laminae 1 to 6. This is the posterior horn. It is divided into 6 laminae. 1, 2, 3, 4, 5 and 6. So the posterior horn is divided into 6 laminae, lamina 1 to 6. And lamina 2 and lamina 3, these together form the substantia gelatinosa of Rolando. Lamina 2 and lamina 3. together form the substantia gelatinous of Rolando. Now, the lamina 7, this lamina 7 stretches between the anterior and the posterior horn. This area is lamina 7. And lamina 8 and 9, lamina 8 and 9, these are the two lamina. Lamina 8 and 9, they constitute the anterior horn. And lamina 8 is situated, lamina is situated medially, while lamina 9 is situated laterally. And lamina 10 is around the central canal. Lamina 10 is present around the central canal. So this is the these are the different rexed lamina present in the grey matter of the spinal cord. Now about the white matter, in the spinal cord, the butterfly-shaped grey matter divides the surrounding white matter. This grey matter divides the surrounding white matter into three funiculi. This is one funiculi, this is another funiculi, and this is another funiculi. This is the anterior funiculi, this is the lateral funiculi, and this is the posterior funiculi. So, in the spinal cord, the butterfly-shaped grey matter divides the surrounding white matter into three funiculi, which are areas of white matter lying in between the horns of grey matter. So these are area of white matter lying in between the horns of the grey matter. The lateral funiculus, the anterior funiculus, this contains the anterior spinothalamic tract. The lateral funiculus contains the lateral spinothalamic tract and the dorsal and ventral spinocerebellar tract, and the posterior funiculus contains fasciculus gracilis and fasciculus cuneatus, that is the dorsal column. So that is about the white matter of the spinal cord.